Hi everyone, today we're going to be discussing about jugular venous pressure. So the first thing before you start off any topic, always ask yourself three important questions. The first question, what? So what is the JVP? In simple words, it is defined as an indirect measure of the pressure in the right atrium, which we clinically observe as the oscillating top of the right internal jugular vein. The second question you need to ask yourself is why? Why do I need to measure the JVP? Why is it important? So 2 points. First one, it is the single most important bedside measurement by which you can estimate the volume status in a patient. The second one is that you can evaluate the right side of the heart, both its functioning and structural integrity by examination of the JVP. So the next question you need to ask yourself is how? How do I do it? That is measure JVP. So in brief, the first thing you always do is ask the patient for consent. Then head and elevation to 45 degrees. Turn the head to the left and observe the IJV course for any pulsations. These pulsations are measured using scales from the sternal angle and mentioned as the same. This is the course of the IJV marked by a single vertical line. So let's discuss the different waves in the JVP. So the JVP consists of three positive waves or ascents and two negative waves or the descents. So the positive waves are named the A wave, the C wave and the V wave, and the negative waves are named the X descent and the X prime descent, which follow the A wave and the C wave. These two waves are regarded as the same descent, whereas the Y wave, which is the second descent, follows the V wave. So we will be dividing this JVP waveform into two different phases, which correspond to the different phases in the cardiac cycle, that is the ventricular systole and diastole and atrial systole and diastole. So the phase that lasts from the beginning of the A wave to the beginning of the V wave, this corresponds to the ventricular systole and atrial diastole. So ventricular systole, as we all know, lasts for 0.7 seconds and is the longest part of the cycle, whereas ventricular diastole lasts only for 0.1 seconds. So this phase is further divided into early systole and late systole. The early systole consisting of the isovolumetric contraction and rapid ejection, whereas late systole consists of the slow ejection phase. Now the phase that lasts from the V wave to the A wave is known as the ventricular diastole and the atrial systole. This lasts for 0.1 seconds. So this phase is further divided into the passive ventricular filling phase, that is when the ventricle is relaxing, and the active ventricular filling phase when the atrium is contracting. So now let's discuss how each and every wave in the JVP is formed. For this, I'll be using a three-part diagram. The first part being the internal jugular vein, the second part being the right atrium, and the third part being the right ventricle. So the right ventricle has its outflow into the pulmonary artery, and these are the tricuspid and the pulmonary valves. So the A wave. The A wave occurs during the end of ventricular diastole and atrial systole. So the atria is actively contracting while the ventricle is actively relaxing. Now know that by this point of time, the ventricle is almost 75% full already. This is because during passive filling is when maximum ventricular filling occurs. So this results in an atria which is contracting and pushing blood into an almost full ventricle already. This results in a flow of blood back into the IJV. This results in a positive wave known as the A wave. So the wave that follows the A wave is the X descent. So this occurs at the beginning of ventricular systole and atrial diastole. So at this point of time, the atria are actively relaxing, whereas the ventricles have started to contract. So when the atrium is actively relaxing, it results in a negative pressure building up within the chamber. This sucks in blood from the internal jugular vein, leading to a fall in the blood column, which presents as the X descent. So the C wave occurs during the early systolic period. This is when the ventricles are actively contracting. This results in a positive pressure buildup within the right ventricle. But this positive pressure is not enough to open the pulmonary valve. However, the tricuspid valve first closes off and then bulges into the right atrium. So this bulging into the right atrium pushes up some amount of blood directly into the IJV. This results in a positive wave which is known as the C wave. This is known as the isovolumetric contraction phase of the ventricular systole. Blood neither enters or exits out of the right ventricle, but the pressure just keeps increasing because of active ventricular contraction. Following the isovolumetric contraction, as ventricular contraction proceeds, the pressure within the right ventricle increases to such an extent that the pulmonary valve opens up. This results in an ejection of blood from the right ventricle into the pulmonary artery. So, when the blood from the right ventricle is emptying into the pulmonary artery, the tricuspid valve, which was initially bulging out into the right atrium, now gets sucked into the right ventricle because of the negative pressure created due to the emptying of blood from within the right ventricle. This negative pressure within the right ventricle thus translates to negative pressure within the right atrium because of the tricuspid valve descent. This results in blood getting sucked into the right atrium, resulting in a fall in the blood column, which presents as the X prime wave. So, in the late systolic phase, the right ventricle is still contracting and emptying blood into the pulmonary artery. At the same time, the atrium is relaxing or is in diastolic phase and is actively getting filled with blood as the tricuspid valve is also closed. So, towards the end of late systole, the atrium is almost full with blood. So, this results in any blood that comes into the right atrium to get regurgitated back into the IJV, resulting in a positive wave. Imagine yourself filling up a water bottle. When the water bottle is almost full, if you try to add any more water, the water is regurgitated back out. This is the same principle which is applied here as well. After the V wave, the ventricles go into diastole and the atria go into systole. During the first half of this phase, the atria are not contracting. However, the ventricles are actively relaxing, and this results in the buildup of a negative pressure within the ventricle. This results in opening of the tricuspid valve and passive filling of the right ventricle. As we already spoke, this constitutes about 75% of the right ventricular filling. Now, when the blood from the right atrium goes into the right ventricle, it obviously results in the fall of blood within the IJV as well. This results in the negative wave following the V wave known as the Y descent. So these six diagrams here depict the formation of the different waves in the jugular venous pressure. Hopefully you understood. Thanks for watching.